All right, so the power rule isn't the only way that you can take the derivative. So other ways that we can take the derivative is using something called the product rule, which is what I'm going to talk about quickly right now. Say I gave you an example, and we'll fill this in a second. Well, quickly, product means multiply, right? So you use the product rule when you have two terms multiplying each other, okay? So, for example, say I give you h of x is equal to 3x squared times, we'll do a simple one, 4x to the fifth, say. Okay? Now, if I told you to take the derivative of this, before you took the derivative, you'd have to multiply the 3x squared times the 4x to the fifth. So when I go through and do that, I end up with 12x to the 7. All right? So, oops, that's not the derivative. That's just me simplifying. So I put the prime there. Got to erase that. All right, so we've got 12x to the 7. What I want to do now is I want to take the derivative. And so now to take the derivative, I can use the power rule, which means I have to do the exponent times the coefficient. So the derivative is equal to 12 times 7, which is 84, x, and now I knock the power down. So 7 knocked down is 6. So that's my answer. Okay? But since these two things are multiplying, you don't necessarily have to use the power rule. If I want to keep them multiplying, then I can do something called the product rule, where I take the first function, which we're going to call f of x when we write out the math terms of the product rule, and multiply it by the second function, which we're going to call g of x. So here's the general rule for, or the math way of writing product rule. It's the derivative with respect to x, that's how you write it, of two functions multiplied together, f of x times, say, g of x. That's equal to the derivative of the first times the second function, which is just g of x, plus the derivative of the second times the first, f of x. Okay, so it seems kind of long and complicated, but what I'm going to do is we're going to take the derivative of h of x using the product rule. So when I take the derivative, I'm going to let the 3x squared be the f of x, and I'm going to let the 4x to the fifth be the g of x. That's in the definition up there. Okay, so when I go through and I take the derivative, I've got this. It says take the derivative of the first piece, the f of x, which is the 3x squared. So the derivative of 3x squared is just 6x, times the second. You just keep it the way it is. That's 4x to the fifth. And now to that, I'm going to add the derivative of the second, which is 20x to the fourth, right? That's the derivative of 4x to the fifth, times the first. Well, the first one just stays 3x squared. Now, when I go through and simplify this, I should get the same answer. These two things should be equal, so let's make sure. I've got h prime of x is equal to, okay, 6x times 4x to the fifth, that's 24x to the sixth, plus, okay, 20 times 3, that's 60, still x to the sixth, and hey, look, when I combine them, you end up with 84x to the sixth, okay? So this was a pretty simple example of the product rule, okay? You've got your definition and a simple example. What we're going to do next is one that's maybe a little bit more intense, okay? So we'll look at this one, okay? Here we've got two things multiplying, right? Oopsies. We've got x plus 8 times the quantity x plus 6, and we're just going to go ahead and take the derivative. And we're going to use the product rule, okay? So when I'm taking the derivative of y with respect to x, you could either write dy dx m tan y prime. They all mean the same thing, okay? is the derivative of the first piece. So we'll call this f of x, and this is my g of x, and we're going to use that rule again. So the derivative of the first, the derivative of x plus 8 is just 1 times the second, which is x plus 6, plus the derivative of the second. The second piece is x plus 6, so the derivative of that is just 1 times the first, x plus 8. Okay, and then when I go ahead and simplify, 1 times that quantity is just itself, x plus 6, plus x plus 8. So when I go ahead and work it out, I end up getting 2x plus 14. And that is our derivative. Using the product rule. Just remember, derivative of the first times the second plus derivative of the second times the first. Pretty easy. Okay? Here is one more example. We've got y equals negative 2x minus 8 times 8 plus 9x squared. So what I'd like for you to do is pause it here and try this one on your own, and then when you're done, check your work. All right, so what I've done with this guy is I've highlighted the first term, or f of x, in yellow and the second term in blue. So now when we go down and we see, what I've done is I've taken the derivative of the first, which is negative 2, times the second, which I kept the same, plus the derivative of the second, the derivative of that blue term, which is 18x, times the first, just kept it the same. That is the calculus. The rest of it is just simplifying with algebra. So my next step, I just distributed the negative 2. And then the last step, I just combined like terms. All right. Let's try another. Okay, and the last example that we're going to try is this one. Y equals 1 over x plus 1 over x squared times 3x cubed plus 27. And what we're going to do is we're going to take the derivative of this as well. But before we take the derivative, you want to rewrite it. You don't want to have these two little fractions. So if I rewrite it, I can write x to the negative 1 plus x to the negative 2 there, times the quantity 3x cubed plus 27. You could just go through and FOIL it all out and then use the power rule to take the derivative, but what I want us to use is the product rule. So let's do that. I've got here dy over d is equal to the derivative of the first. So you're going to use the power rule to take the derivative of that first thing. It's going to be negative x to the negative 2 minus 2x, and my new exponent is going to be negative 3. The derivative of the first times this second piece times this, 3x cubed plus 27. And to that I will add the derivative of that second piece, which is 9x squared, times the first, which is x to the negative 1 plus x to the negative 2. That is the piece of calculus. Now the rest of it that we're going to work out, that's simply algebra, things you've been doing since 9th grade. You just have to be careful with the negative exponents. When I do first times the first, you add these two exponents. So I've got negative 3x, and then I've got negative 2 plus 3 is just to the first, so I'll leave it like that. Then I've got minus 27x to the negative 2. Oops. 27x to the negative 2. When I multiply these two guys again, I'm adding the exponents, so I have to be careful here. It's going to be minus 6 Negative 3 and 3 is 0, so that's x to the 0. X to the 0 is equal to 1, so I'm just going to write minus 6. I don't have to write x to the 0. And then the last thing I've got is 2 times 27, which is 54. So minus 54x cubed. So that is this binomial all FOILed out. Okay? Then I have to do my last piece, which is 9x. Remember, adding exponents, so that's just going to be to the first, plus 9x to the 0 again, so I'm just going to leave it as 9. All right? Now the last thing, I'm just combining like terms. I always like to start with the highest exponent, and in this case that's going to be the negative 54x cubed, and then work my way down to the lowest exponent. So I've got negative 54x cubed. Then combining like terms, I've got negative 3x plus 9x, so that's plus 6x. Minus 27x to the negative 2. And then I've got negative 6 plus 9, which is positive 3, plus 3. So this is the derivative. You could either leave it like that, or you can rewrite it. And instead of putting the x to the negative 2 in the numerator, you can just write it like this, if you'd like. Okay? So that is the answer to that third example.